Hello guys, welcome to a new tutorial about the Kuka Sunrise toolbox. In this tutorial, I'm gonna be talking about the soft real-time control functions of the toolbox. So first of all, open MATLAB, then change the working directory of MATLAB to the folder MATLAB client. You can find this folder inside the Kuka Sunrise toolbox package. So you go and from inside the MATLAB client folder, go and open the tutorial direct servo script. So this is an example where the soft real-time control functionalities are used to control the robot in joint space. So the idea is to control the first joint of the Kuka EWA in order to move in a sinusoidal motion. The control is performed in real time. So right now I'm going to be explaining about the code. So first of all, I'm using close all, clear all, and CLC. If you do not know those three instructions, close all is used to close all figures or other connections that you have. Clear all is used to clear the variables, your workspace variables. And CLC is used to clear the command window. So here I am using warning off to turn off the warnings. It's not important to use it. It's just there. What it does, it turns off any warnings, so MATLAB doesn't give you warnings. So here in line 20, we are going to start with the real coding. So first of all, you have got to define the IP of the robot. Then here I am declaring global variable, calling it tkuka, and I put inside it the TCP/IP connection object. This object is returned back after calling the function let establish connection, which is going to establish a connection with the MATLAB Toolbox server application from inside the Kuka controller. So here afterwards, I'm going to check if the connection between the robot and between the controller has been established. So the idea is if this variable doesn't exist, or if it is empty, or if the status of it is closed, then it's gonna display this message that the connection couldn't be established, and then the code is gonna be aborted because you have here the return instruction. Now otherwise, if a connection is established, the program is gonna proceed. So here I am declaring a cell array. This cell array I name it JBoss, and it specifies the joint angles, destination joint angles of the robot. So first of all, I'm going to take the robot to some initial configuration. So this is why I use JBoss. I use JBoss in order to store this initial configuration. Then I am gonna turn on the blue light on the robot, just to signal that the program has started. So then I define the relative velocity by which I want the robot to go to the initial configuration. Then I'm gonna move the robot using the point-to-point motion functions in joint space. I'm gonna move the robot to the initial configuration where all of the joints has a coordinate of 0. So this function move PTB joint space takes three variables. The first is the TCP/IP communication object. The second one is the cell array of the destination joint angles, and the third argument is the relative velocity by which the robot is going to move. So the relative velocity shall be from 0 to 1. Do not forget that. Now afterwards, when the robot is in this initial configuration, I'm going to start the soft real-time functionality inside the robot. So I'm going to start the direct servo inside the robot. Now I'm going to be speaking about the direct servo and the soft real-time functionalities in detail in more advanced tutorials. But in this tutorial, I'm going to just show you how to use the soft real-time function in order to control the robot in joint space. So here it's more a practical tutorial. Later I'm gonna give a theoretical tutorial about how to start, what is the direct servo, and how the program is structured, and about the other technical details. It's gonna be just for advanced users. So here we start the direct servo in the joint space, and you have to send to this function an argument, which is the TCP/IP communication object. So afterwards, I define the frequency and the amplitude of the sinusoidal motion of which the first joint is going to move. So the frequency, I use 1.5 radians per second. Then the amplitude is going to be pi over 6 or 30 degrees. So here I define it by radians. Then I'm going to use a counter. This is just to count the number of messages that I am sending stream to the robot per second. So it's going to be used to calculate the transmission rate. So afterwards, you are going to initiate some timing variables. Those timing variables is r delta t. This function is gonna hold the time since the initiation of the control loop. Here I initiate this at tick, which is this is a MATLAB instruction that is gonna initiate the timing. So once you call this instruction, tick, the MATLAB starts to initiate the timing. Then I use toc. Toc instruction is gonna return to you the time. So I store the returned time. It's going to be returned back in seconds. I store it in a variable. I call it t0, and this is, I consider it as the initial time of my control loop. So here I have the control loop, and I'm going to say while the elapsed time since the beginning of the control loop is less than this timing constant, then the loop is going to be continue executing. Now this timing constant signifies that the first joint of the robot is going to move in a sinusoidal motion in 6 cycles, because each cycle is going to be 2 pi, and in such a way this timing constant corresponds to the time at which the first joint performs exactly 6 cycles of motion. Then I'm going to in each iteration the program is gonna call the function toc in order to get the time. Then I'm going to calculate the elapsed time since the initiation. Afterwards, I'm going to calculate the coordinates of the first joint. Now if you need to perform a sinusoidal motion with a frequency of omega and an amplitude of A that I have defined before, you have to use this function. Then I'm gonna increase the value of the counter by 1. Then I'm gonna stream the joint positions to the robot using the send joints positions. So the toolbox provides several functions that you can use to stream the joint positions to the robot. This is one of them. This is the easiest to use. So in this more simple tutorial, I'm gonna use this function in this tutorial. Now for more advanced tutorials, I'm going to be speaking about the other functions that you can use to stream the joint positions to the robot. This function is satisfactory. There are other functions that are more advanced, which give you more options or faster execution and some other features. So right now for this elementary tutorial, this function works well in order to stream the joint positions to the robot. So to stream the joint positions to the robot, you have to use this function and you have to give it two arguments. The first argument is the TCP/IP communication function, the TCP/IP communication object. The second argument is a cell array of the joint position destination.